Yes.
Oh no, you have this. Oh. It's really good.
Yeah,
Okay.
Now all my tiramisu supplies are finished.
Let me sick your mind. Great stuff.
What cream it is?
Mascarpone.
I don't know what it is.
It's technically it's a cheese
And then you think that tastes really soft.
with eggs.
You can stop.
Yeah. I'm just gonna go give it to Kristen a piece.
And cake there, is that like sponge cake?
It is biscuits, technically.
But it's soft.
Yeah, you soak them in coffee. Espresso. This is my piece. Okay, I will quickly give. Yeah, something. Yeah, this term we finished.
No, it's not working. Rosalia,
It's not working.
remove this adapter. Yeah, or you need another one because I think if you do not work with that one, maybe you will need yes from there. So let me remove this one.
Or you don't need to be.
I can-
you can connect it to that.
Yeah.
Would you need that anything?
Yeah, after because at the end I have prepare like one exercise for them and then for that I think we can like break out.
Break for the-
Yeah.
While they're doing the exercise or after?
Yeah, why?
They're doing
Is
the.
Koda helping today?
No, they not
He's not polio.
He was helping.
they went for the vaccine. Polio vaccine.
How many people do you want me to put?
I think for that we will have five gonna be available, me and maybe you, but maybe only two. Yes.
Oh.
Only two. Because just after I finish, I ask them to do like the same thing, but it's just different Raster file.
So, how long do you want the breakout rooms for?
20 for this time.
20 minutes.
Yes,
Yeah.
because just like at the end, for example, when we finish up to here, now I ask them to use the mask.
Did you email this raster script schedule?
Yes, the skeleton, yes, on Friday. The skeleton, I emailed it.
Find it. This one, raster. Oh, what is this Wi-Fi? Is it EWEZ?
No, it's M
Airtel?
something.
Yeah, MO16 Tigo. And that's the password. MO16 Tigo.
Yeah.
I mean, I can't say it.
But I was thinking also, I told them that they should prepare to
The
pitch.
pitch.
Yeah.
Yeah, so we have to have extra 15 minutes.
Yeah, like 5 minutes per girl.
Well, Annabelle submitted a concept now.
She submitted a Word document.
Yeah, so I put a comment on her thing to be like, can you put who your team members are?
Mhm.
So I don't know if she's worked on it with the team. Yeah, I can't find it. MO you said.
Yeah, MOA.
Yeah.
MOA.
And EW is a Airtel.
No.
None of them.
He's so sure.
No. Yeah.
I don't remember on the list.
And trying to on. You want to? Oh,
Time, I'll use my data.
wait, sorry.
Even me, I click the other network
Hmm.
to be able to find it.
Yeah, I did that. I opened the whole thing.
Oh,
Oh, yeah.
it's Saturday.
Oh, does it have any key?
Maybe.
Yeah.
That's fine. I'm on my, I'll just use my own data.
Yeah.
But also I don't want that to run out for him.
Yeah.
Recording in progress.
So we should have the announcement that we want to hear their papers at the end of this. So just so you know.
To tell them at the beginning.
Yeah. Has anyone given you any reason for not attending today?
I just look at my ones. So. I didn't like to watch it. But I have the notebook.
Oh, that's more.
Yeah, so only Kaiser. It's because it's getting the polio vaccination.
Hello, David. Okay, yeah.
Should I put in the picture?
Video
The comment.
because I want to optimize internet, but
Oh, I
hey, yeah.
All right.
Where is a small remote? Yes.
So, yeah, so today, folks, we may not put our video on because we're having a bit of an issue with internet. So just for a little bit, we'll keep it on and then we may just keep it off for the
Yeah.
rest of the time.
It's not working.
No, it's there. You need to select them also then.
Yeah.
Have you selected the logic panel?
Yeah, it's on logic.
So it's frozen. I think the internet is just too low.
Yeah. Mhm.
So it's okay, just sort of the video then. Mm.
Yeah.
Hi everyone. I hope you had a great weekend and you're excited to continue with this other session on spatial data. So just a quick reminder, at the end of the session, we'll have the pitch sessions for the concept notes that you guys have been working on. So please do stay up until the end. We'll make it really quick so that we don't take too much of your time. Otherwise, I'll hand it over to Usman.
Yeah. Thank you, Nema. So, can you hear us well?
Yes.
Okay. Thank you so much for joining. So, today we are continuing about spatial data, especially with raster. So, let me share my screen. Can you see on my screen?
Put it swap display.
Oh.
Yeah, we're good now.
Okay. So the last time we learn about the spatial data, so and we make a focus about vector data. So today we are learning another component of spatial data, which is raster data. What is raster data? Raster data is a type of spatial data represented has a grid of cells or pixel, where each cell has a specific value representing information about the area it covers. So, for example, you can see here we have a grid where you have this cell, and it's how raster data is designed. So every cell, or we call it pixel also, contains information that we want. And the size of the pixel or the cell determines the resolution. And for example, we can have continuous variables such as population or elevation or rainfall, or discrete variable which has land use. So you see, for example, in this raster grid, we have these small cells represented by column and rows. So this is how raster is designed, and every cell contains the measure of your variable of interest, and it can contain over more than one variables in every pixel. So to manipulate the raster data, we in R, because we are more focused here in R software. So we have to use some function which are in some packages. So the original raster package is raster, the same name, uh, which use the function raster as is described here. So this was the original legacy package for grid data. While it is widely used in all the tutorials and code bases, it has been officially superseded by Terra. It means that there is improvement or new feature added from this raster to get the new packet, which is Terra. And Terra packet is using the function Rast to read a raster file. So we can conclude that we have these two packages, raster using the raster function and Terra using the raster function to read a raster file. So for the documents, raster files have commonly formats like GeoTIFF. I think most of you have been explored or analyzed this data which are TIFF extension, but we have also NetCDF, ASCII grid, and EMG. So I can say the most common, which is a TIFF extension. TIFF represents target image file format, which is a flexible, adaptable format for handling images and data within a single file. It supports various compression methods and can store multiple bands or layers of data, example, red, green, blue in satellite imagery, or multiple spectral bands. Example here, if you have a folder, you can see this folder contain multiple raster file which are in format TIFF. So when you open or read a TIFF file with the function Rast from Terra package, you are seeing something like this. So you have the class which is span raster, showing that it is raster. So you will see also what will be the class when you read with a raster function coming from raster package. And also we have dimension representing here the number of rows, this value 258, number of column, and what every pixel or cell content, how many variables like or that we can call layers, which means that here you have two layers modules in every pixel. So we also have the resolution. So remember we talked about coordinate reference system last time. So for the resolution, you can have it in degree or in meters representing the type of coordinate reference system that you are using. And we have also another component which is extent. So for the extent, it represents your bounding box around the raster. It means your minimum long lat and your minimum and max long lat and min and max latitude. And you have here the coordinate reference system, which is a default one, WGS, that we already know now from the first session. And it has the name of your life, but also it shows the minimum and the maximum values of your life. So dealing with raster data give multiple advantages. So Raster data are good for representing continuous data, such as elevation, pollution levels, but also it they are easier to be manipulated and analyzed with mathematical function. For example, you can use raster layer to calculate average or mean or make sum. Also, they are compatible with remote sensing data, which is inherently raster based. But they also present some disadvantages. Yeah, the name is not correct, sorry, because they require large storage space, especially at high resolution. So, has resolution you can have like 1 kilometer square, mean that your cells or pixels that I show you in the grid, they have 1 kilometer in it's 1 kilometer square, but you can have less, which represent high resolution or more, like 10 kilometer square or 5 kilometer squares, depending on the level of aggregate or your data. So for having this raster data, we can make projection, but we need to be careful. It's not very simple like the SF objects that we learned before. So when projecting these raster grids, you must resample, because when you project, you are moving some cells. So it means you are creating new pixels that should have also new values, which can be obtained by resampling. Common resampling methods include nearest neighbor for categorical data, like land cover, or bilinear for continuous data, like elevation or temperature. For example, here, when you have a new raster, here is an example how to create a raster. For example, using the function Rast, you have to add the extent and then create cells. It will give you a raster, and for this raster, you can give it a CRS. And then when you are projecting, you have to use a function project coming from the Terra packet, which take your raster file plus your new CRS that you want to use. For plotting raster files, we still have the default function, which is plots. We will see concretely how this works during the practice time. But we also have the very fancy function, which is ggplot, which require here the geom raster described here. So we can also have some additional functions, like we have X. If you want to check the extent of your raster file, you can use the function X. It will give you the extent, like the mean and max of your longitude and min and max of your latitude. So we have the function res, which give you your resolution of the raster file. So for this raster file, we can add some other components named crop, which allowed us to adjust the bounding box of the raster to the polygons that we are using. For example, if we have a country like Tanzania and where we have the shapefile and we have another raster layer like the population raster. For example, when you plot your population, it might not give you the real boundary of Tanzania because of the grids. You can have some external grids out of Tanzania country boundary. So to correct that, we have to crop, but also mask in order to get something which is only mostly inside the Tanzania boundary, country boundary. So we can also use function aggregates. For example, we can have a resolution of 100 meter, but we want to work with 1 kilometer. So for that, we use the function aggregates, as described here. And from 100 meter to 1 kilometer, you need only 2 times 10. And we will get to 1,000 meter, which correspond to 1 kilometer. But also, we have the function sample to match the extent of 2 layers and be able to do some maths. So we also have the function extract, which allows us to summarize the raster to the district level. For example, if you have the population raster for Tanzania, but you want the values for every ward or council level, you have to extract these for the shape files that you have. And then you will have for every polygon one value from the raster. I think I don't know if we have question from the chat. If not, we continue. So after all this, now we are jumping to our session. So let's open the studio and then start to fill the skeleton. I hope everyone has received the skeleton R script.
Hi, Usman.
Yes.
So, for in my side, I saw the R skeleton script, but I did not see all the material, the TIFF that we really use today.
The data.
I don't know. Yeah.
So
the data entry.
yeah, did you get that email properly?
I received, yes, I received, but I saw just what you sent the past time. I did not see all the something like fill TIFF file. I didn't.
So last week, I sent you the material like the data of a folder named data and script for vector data. But when you open that folder containing the data, you have your shapefile, your CSVs, and your raster files. in that folder. And last week on Friday, I mentioned that we are going to use the same folder. It's why I didn't resend again, because you already have it normally.
Okay. Okay.
Yeah.
So I was just thinking it was other thing that I did not see instead what you sent the past time.
Yeah, the data I already sent them before. It's why it's not necessary to do it again. Yeah.
Okay.
Okay. No more question. Thank you, Asa, for asking.
Thank you.
So, if not, we are jumping to the art session. So, let's everyone open the R studio and also point the R console to the folder where all the material is stored. So for me, the data and the script, like all the material related to this session is saved in this folder that I call spatial data. I hope everyone can do that. Yeah.
And can you just confirm you can see his R studio? I can't see your R studio, I see the slides.
Okay, let me. Okay, so I am sharing my R studio. Sorry.
Can everyone see the R studio windows? Yeah.
Okay. So Arsen, if you open this like this, so what I'm talking about. Last time I sent you this, and here in this raster folder, you have all the TIFF. You see, the TIFF files are here.
Sorry, man.
Yeah.
So if it's possible to resend it, but I did not see it. I don't know why. Yeah.
The data?
Yeah.
Okay, I'll forward it to you.
Yeah.
Okay.
Is it okay for the rest? So today we are going to work on this R file. We are not creating a new quarter document, but I hope everyone was able to do that last time. And for this session, we are going to work with these different packages. So we are going to use the Terra packets in order to read raster file. So you can load these packets. If you couldn't, it means your package is not installed yet. You have to install it first. But the other way also to read a raster file is by using the function the packet raster. Let's do that. And we also need the SF packet in order to read our shapefile. Is this okay for everyone? Okay. So when you open the data, as I said here, you have this raster folder again, and when you open it, you have this different key. So we are just going to read one from these rasters. With first we will use the function rast from Terra package. So just replace here by rast, and then you click read, you run it. You see, I'm able to run it. Please, if you have issue or some error, let us know by the chat, or you can open your mic. So let's print this raster file to check what it contains. So when I print it, you have this different information that I already described in the slide. You have the spark raster, you have your size here, number of rows 84, number of column 156, and one layer, means it has only one variable. And you have your resolution, you have your coordinate reference system, your extent, mean your min max of the long and large. So, and you have the min and max values here of your variable. So now let's inspect these objects by using this different function here. So you see, when you print your raster file, you have all this information. But if you want to check maybe some specific information, you can use this different function. For example, let's use the function CRS, and we put our raster inside. You see, it's going to give us the world, the coordinate reference system, which is here, so WGS84. And we can use the function X. These functions are from the Terra package. And function X. So we run. So you see, it's giving us the extent value, the minimum and maximum of your latitudes, and the minimum and maximum of your longitude. So you can also use a function res. So the function res give us the resolution, which is in degree here because of the WGS84 reference system. So we can plot this raster by using the function plot. Here main give us only the title. So let's plot it. And now you have the plot here, and you can see it's not representing for maybe any specific countries that you have. It means this need to be refined by some additional as a function in order to get something very clear. So you can also try the same, but now for using the packets raster via the function raster. So let's test it. Function raster. Because already loads of package raster. So you after running this the same raster file with the function raster now, please print it and tell me what are the differences that you are showing between this object with raster and the default one with Terra. Maybe let me do this. I will say here Rust. So I am running this specific with the function raster. Yeah, raster. I call this object raster. The first one I leave it like world cup. So now let's print this consecutively to see maybe what differences you can observe. If you print this here, you see here the I need to run again this to have the default one. Yes. So let's print it. Okay. So this world raster is a file running with raster function from raster package. And here world is a file running with Rust function, Rust from the Terra package. So let me know what are the differences that we are observing here. Can someone explain the differences here? So it's very important to know what function was used and how to manipulate it after, because you somehow have some script and then maybe you have to know what function exactly was used and why the following script is using some kind of function which are more adapted maybe with Terra packets than Raster packet. No one?
Osman,
Yes.
looks like in Terra package we don't have the SRS. It's correct, like the projection.
The projection, yeah?
Yeah,
With the Terra packet.
yeah,
Oh,
But we do, we have the
Yeah.
coordinate reference.
see here.
yeah.
They might look different, but they
Yeah.
are the same thing. So the one above, you can see it's called CRS.
Yeah,
Yeah, exactly.
yeah.
Yeah.
And then the class. When you see the class here,
Yeah, it's different.
for the raster function, we have raster layer. And for the Rust from Terra package, we have Spark raster. Okay, let's continue. So for the raster files, you can have a variable which is measured in different periods, and then your folder can contain many TIFF files, but your analysis needs all of them, and it's very important to know how to read all of them in one time instead of reading one by one all these temporal TIFF. So for example, let's start with this maybe basic one where you decide to read one by one. For example, here we are reading the file observed in January 2018. We are using the function Rust from Terra package. So we read this, and the second one is the file for February, and you can continue to do that for March, April until the end. But you know this will take time and it's not very efficient. So the best way is to read all of them at the same time. But for those to do that, you have the function list.file. This function list.file, which takes arguments like path, sorry, what's path? It means you have to be in where your TIFF file are storage. So it means here we have to go to data and raster. So we have to be here, raster, here. Can you click? And you have to be here where you have all your TIFF file. And then from this, you want to read these TIFF files with the pattern. Pattern is means the names of the TIFF file. You have one word or something which has this GPMM. So it means all your files here containing this pattern GPMM will be read. So this first thing, like doing this, the file name must start with GPMM. You decide to read your files in this way, starting with this pattern. And this symbol means starting of the string object. And then you have dot start question mark, which is 0 or more arbitrary characters in between. And the question mark can indicate no greedy matching in some, yeah. It's like to be very, very, very careful that you are calling the right component. And then you have the last part dot TIFF with this. The file name must end with TIFF. So you are reading file names starting by GPMM and ended by TIFF. All of them in this folder will be taken account. So let's do that. Let's run this file name. And then from this, it only creates like a list of all these files. It's not reading now, it creates a list of all these files. And then when you want to read them, you remember you have the function Rust, which is going to read all the list of your files containing in this object. And let's check what are the different files here. When we plot them, we are seeing multiple plots of all your yes.
Sorry, can we stop? So the folder, the zip folder that I think you shared
Yeah.
does not have the raster data.
Oh,
So Sylvian has just sent me a snapshot of the photo and so has Witness.
yeah.
And there's CSVs, there's shape files, but there's no folder called raster.
Oh, okay. So sorry, it was my fault. Maybe I exclude on that time the raster data. So
So everybody, I'm gonna put a zip file of the data folder again. And I'm gonna see if I can put it in the chat so that you all can download it for everybody.
yeah,
So our deepest apologies, guys. But thank you, Witness, and thank you, Sylviane, for highlighting that.
and Arsen also, yeah.
And Arsen.
Sorry guys, we are sending you the raster.
Usman,
Yes.
therefore, until now, I was struggling to look for that. I didn't see.
So next time something like this is happening, can I please ask you guys, you need to speak up.
Okay.
The more you guys speak up, the more we know that like you're not following on.
Yeah.
Yeah, it's Vic who tried to send it to me now. I'm not trying to.
No problem.
Yeah.
So it's in
Okay.
the chat. It's in the chat. Let's give you guys a minute or two to just download, unzip, and put them in your folder. And
Okay.
then we will, Usman
Yeah.
in 2 minutes can walk through again, just loading the first World Pop raster.
Okay. Thank you.
Yeah. Ah.
I didn't realize either.
Yeah. So
So Jason is listening.
He was struggling because he was in the last session.
Did he join the
No,
Did he join the focus?
he did, but I think he was struggling, so he's supposed to go watch the videos. But he'll come back at noon, at 1 o'clock.
Oh, okay. Then we have to catch up.
Yeah,
So please let us know if you have done is downloading the raster data.
Please, Usman, is it the same that we used last time?
It seems like the last folder for data that I sent last time didn't have these rasters. It only have CSVs and the shapefiles.
Yeah.
Now we are going
Okay.
to provide you the rasters.
Okay.
So-
Because from my side, I see the folder that we used last time have the raster file inside.
I'm very confused now.
Okay.
All right, so can we get a thumbs up from those that have the raster folder, so we know to move on? Okay, great, Victor, Sylvian, Dowdy. Babalola, do you have the raster folder? All right, we'll give you guys another minute to download. It is in the chat, the data folder. But as soon as you have downloaded it, can you please put a thumbs up? Because only 3 so far have given me a thumbs up. Thanks, Victor, for sharing the screen. Witness, great. I'm glad you have the raster folder now.
Arsen,
Yeah. It's okay.
it's okay now. Okay.
Yes.
Now,
Babalola is commuting, okay? Annabelle, do you have the raster folder?
I just downloaded it now from the chat.
okay.
Preparing the listening folder.
So for those of you that have the raster folder, because that's a large majority, please put again a thumbs up if you're able to load the World Pop raster and have World Pop in your environment. Thank you, Victor. Always number one.
Yeah.
So just as a reminder, guys, make sure that your file path or your working directory is pointing to that new data folder that you've just downloaded.
So just you have to download the raster file, please put it in the same folder where you have the CSV and shapefile, and don't change the name. Just put it in that folder, and then the script will be conform with your path that you already create with CSV or your parts. Put it here in this folder data. Please let us know if you are ready to continue.
Thanks, Sylvian. Thanks, Arsene. Annabelle, are you ready to continue? I think you're the last one.
Almost, I think we can just press it.
Dowdy, have you been able to download the folder and get it working? Great, thank you, Dowdy.
Okay. So if that is the case, so just read the population raster file here with the function rast, and then as I already described all this, just try to run to see if it is working correctly. If that is the case, you can now run the multiple files by first creating a list of all these files name here. Not you have not to change anything here if the path is correct. After that, you run your raster files, and then you plot your raster files here, and you will get something like this, where you have this multiple raster mapping. Can you tell me if you reach up to here? Sylvia, are you able to read this?
Yeah, she gave a thumbs up.
Okay. Daudi, Tao or Babalola?
We have Tao here today.
Oh, okay. Arsene?
Yeah, it's okay for me. I'm there.
All right, so let's
Okay.
continue.
Okay. So, maybe let's see now what are the names in these raster files. So remember, we have to use the function names. So you see here, these raster files are named like this, which is very long. So we can decide to create our own short names. For example, here, this file called the total 2080.04, it means April. So we can create a very short name like this to replace this name. To do that, we use the function names, and then we create a vector of names which has the same component of your number of files. Here we have 12 files. You should create 12 names. And as you know that it's represented monthly, you can add monthly. And you have not to change your order. Your files start from January to December. You have to make your names from January to December. And then when you run this and we plot again, so for example, if you only plot one, like your map in June, so you see what we are getting is a short name that we just created. So when you don't do this with this list of rasters, it will give you all your 12 months. But as it is a list, you have to make this double bracket and then make the position of your maps to give only one maps. Last time we showed it with the shapefile. For the shapefile, you have only to put a single bracket, not double, because it's a data frame. So now we would like to read this via ggplots, but ggplots required a data frame with your coordinate. So now we are going to transform our Spark raster to a data frame. To do that, we are going to use this function has.data.frame. It takes a raster and give longitude, latitude, and XY coordinate. So let's read this one. So now let's check what it has. Remember, if we read only GPMM, it is like a stack raster. It has many components, many layers in the same raster document, raster file. And you have this, the different modules are here from January, February. It has design like this. But now, if we transform it to a data frame, let's check it. We can here click where you have in your environment where the variable is, or just use the function view gpmmdf. So when you read that, you see how it is designed now as a data frame. You have columns and rows not represent the number of your pixels or cells. So you have your different column names here represented by column. It means every rows represent one single pixel or cells, which has longitude, latitude here. So after doing that, now we want to represent the maps by months for the same variable. Now we need to transform these row columns by long format. It means all this from your January to December, it has to be in one column and just differ by months. To do that, we have to use this pivot longer, taking your data frame, which has columns of your same variable but in different months, where these column names has a pattern GPMM, And then as they are varying by months, you set the names to months, and the names of your columns start with GPMM. You set the named prefix by GPMM, and then you know what is your variable. It is rainfall, so we call it rainfall, or sometime precipitation. It's up to you to name it like that. So now we can run this. It means that we have a problem of another package which use pivot longer.
Can we ask the group, could you tell us what library we might need to download to find the function pivot longer? You can put it in the chat. What library might hold the function pivot longer?
I'm waiting for you, please.
Thanks, Annabelle, you are correct. Thanks, Sylviane, tidyverse, yes. And within tidyverse, there's the package dplyr.
So tidyverse is a general one. It has many other sub packages also, but let's use it. Maybe it's going to, you see, it has very much other packages. So now let's run again. It solved our problem. So just let's have a quick check. So now you see what we have created. We still have the latitude, longitude here, and we have added a new columns, months and rainfall. Months here is taking your 12 months. Rainfall is taken for every month, every set of X and Y, you have one value of rainfall. It means every cells in every month. Now, after getting this, we can use our ggplot, where we have our new data frame in long format. We have X and Y, and we have also variable rainfall, which is described by months. But we need here the function Raster, which will give us to draw for every pixel represented by long lat all the values of our variable. So just put the Raster here empty without doing anything. And now let's run this to see what we are getting. Very nice maps compared to the ones that we created with the function plots. You see, they are more cleaner, but as I mentioned, they still need to be refined in order to represent one specific country. So another alternative to do the same plot here is to set now the different argument in the germ raster. So can you do that and tell me if you succeed? We want to make the same plot, but now ggplot bracket will be empty, but you have to fill in germ raster. This one. Tell me please if you have successfully run this. And also if you struggle, tell me also. Who are able to run this?
I think give them another minute.
Okay, yeah. Just to feel something here. Okay. Can you tell me if you are able to run this by changing the argument now in GeoRaster? Just make a sign in the chat. Sylvia?
Yes, will be answered. Yes.
Yeah. Victoire, I believe on you every time. Baba, also I believe on you. Jason or Witness?
Jason and Babalola.
Yeah.
Jari struggle.
No, Babalola has dropped.
Drop. Oh.
And David has dropped.
So
Did Babalola give you a reason?
okay. So who are struggling to run this by making the change? So Sylvia, can you tell me what did you do here?
So what I did is I just put the data instead of the geom raster functions and also the aesthetics x equal x, all of that, just to paste instead of the geom raster.
Okay, you copy this and paste it here
Yes.
by adding data equal.
Data equal. Yes.
Okay, so let's run this to see. Perfect, Sylvia. Thank you so much.
Thank you so
Let
much.
me, yeah, the other guy, if you struggle to do this, please let me know. So you see these maps, so they are very wide, so you cannot maybe imagine that they are representing for any country specific because they need to be refined. Now we are going to refine this and adapt this to a specific country file and then see the result. So we can have like 3 minutes break to allow people to take coffee or water and we come back. 3 minutes.
So I think you really need to show them that if you switch off chord equal,
Mhm.
you create a distorted map.
Okay.
Because you need to hone in on the fact that chord equal always needs to be there.
Okay. Then we come back, yeah.
3 minutes.
3 minutes, yeah. Okay, great. So let's continue. Are you all here? Okay, so one important thing to be highlighted here is this code equal. It allows you to do not distort your maps. So for example, let's comment this and check what we can get. If we run this without code equal, so you see we are getting something bigger. Here maybe we cannot like have a very nice understanding, but if it was a real country, you will see how your map has been distorted. So to avoid this, you need to always put code equal for this raster mapping to maintain your maps without this distortion. So this you need always to have this in your ggplots mapping. So you see now it's not it doesn't have much it doesn't be much bigger because before it was distorted. So after that, let's use again our shapefile. So we now want to link that shapefile to our rainfall to be measured within the shapefile boundary. For that, we need to read a specific shapefile. We are reading our previous shapefile, FACLAM. So to read the shapefile, remember we are using the function stread from SF package. As we already load the package before, now we are just reading it. So after reading this, so we have the shapefile, it's in polygons, remember? Now we need to convert it in a sparse vector in order to use the following functions. So to use the sparse, to convert the shapefile which is on the polygon to sparse vector, we use the function vet. Vet here, you take your shapefile, original shapefile, and now if we check the class, it is sparse vector. So after that, we have our shapefile, we have our raster. Now we are going to use the function crop. Remember, the function crop help you to adjust the bounding box, the extent. And first, maybe let's check the extent, because you see here the extent of your shapefile is this. So if we check our extent of our shapefile, GPMM, maybe just take this. You see here the extent are minus 1.5, which is less than this minimum. Okay, if you compare, it means this has a larger extent than your shapefile. And if you see the maximum here, the maximum is 10.5, but your shapefile has max y 10.3 something, which is less. It means there is not matching of extent. So to have matching of this extent, we use to use the function crop. For that, we start with our shapefile here, GPMM. No, our raster. We start our raster. So and then we add our shapefile here. Take land, which is vectorized. Okay. So and then we run this. So we run this. Now let's check what is the new extent of this cropped raster. We are using the same function on X. So now if you compare, the initial one was so we want this in the same month. Let's do this. But more of the months. 6 June. So yeah, it's the same. So when you compare now, before it has this extent for the minimum, X min, but now it has this. And when you see for your geometry, it has almost the same. Now for the
There's a question from Annabelle.
okay, yeah, Annabelle, go ahead.
Yeah, hi Osman. I have a question. At what point, maybe you mentioned it, but I didn't hear it. At what point am I supposed to put the raster as shapefile? And does it mean that all the time in all data sets I have to do this?
So, what I explained, you see, for example, let's show this shapefile. Let's plot it and see how it looks like. So, for example, you see the shapefile represents these country boundaries, and you see how it is limited and how the polygons are. But if you check your raster, you see how they look like. It means they have not the same form. So it means the cropping will help you to reduce your grids, your raster grids. If it was like larger than your shapefile, it will help you to adjust the boundary to be, if you are here, your x and y will not exceed this x and y and x and y boundary. You see, it will limit your boundary to the shapefile extent, and after that, to have something exactly like this, you have to use the following function mask, which can now transform something like this to exactly like your shapefile boundary. It means your shapefile generally can exceed the shape, your raster can exceed your shapefile boundary. You can have some values of your raster out of your country, for example, if you are dealing with your country. Because remember, it's like satellite images, so it can give some values out of your country file. Now to adjust this to your country X and Y limit, you need to use your function crop, and then after that mask to have your variable measure within the country boundary. Is that a bit clear?
Yes, thank you.
Okay. So after cropping,
Victor has a question.
yeah, Victor, go ahead.
Yeah, just I want to be sure that I'm in the good way. So it means that we can do the same like it's also the district level, like admin 1, admin 2, then
Yes.
using the same approach.
Yeah,
Whichever polygon you have.
yeah. It means just you have a polygon, you have a raster, you
Yeah.
want to be sure that the values that you are using, they are all within your polygon boundaries
Great, thank you.
outside there. So first here is not allow you to be entirely in your country boundary, but because you remember the grid, you have this square like square form. It means even using the function crop, you can have in some form, for example, if we are in your polygon.
Can I just help you here?
Yeah.
I think the best way to describe this is to actually show it through a plot.
Okay.
So if you can paste the ggplot
Yeah.
and then add the geom SF of fake land to show them the boundary.
Okay. This one.
So here's an example. If we go back to our original plot, right? And we are gonna copy it. And then we're gonna paste it, which one did you do? Cropped.
Yeah, crop.
Under the GPMM cropped. Right, we're gonna change the data to use this GPMM cropped. All right, now just run this first.
Yeah, because
It's not fortified, is it a?
because this crop didn't use a long format where I create this.
So then remove the facet wrap.
Yeah. Maybe let's take only one.
Yeah.
Maybe just fill. Let's see what its content.
So if anyone can help him out here and
Done. Yeah. EP.
okay. So folks online, you guys have been learning, can you help out your teacher? How would he make a plot of this cropped spat raster?
Yeah, I have to transform this in data.
So tell him what is he missing? So, no, we're actually gonna now stop here because if nobody answers, we're going to end this class here. I actually want to see if you guys have learned something. So you now, this is a real life situation. We don't always have the answers. I want you to help Usman make this plot. How is he going to plot this new cropped Spat Raster. You are more than welcome to unmute yourself, talk, put it in the chat, but I would love to hear someone tell us. Otherwise, for the next 35 minutes, we're going to sit here in silence.
Yeah. So we are ready for you.
You need to help your teacher. How is he supposed to make this plot?
So just this scroll what we have described before from your raster data. Because if you just check this, you see it is in Spark raster. And then we made small change before in order to use a ggplot function before.
I think maybe I am wrong, but I think because the GPMM cropped is not a data frame, then it's not allowing us to use the geom raster function yet here. So we have to transform it to a data frame first.
All right, wonderful. Pass your laptop. Now tell me what steps you want me to do. You are now my instructor. I want you to tell me what the steps are. So you said I need to transform my data that's here, this GPMM prompt.
Yes.
All right, how do I do that? I'm taking it out now. What do I
So
do?
maybe, so we say we name it like GPMM crop DF, like just data frame, and as point data frame, the GPMM cropped.
So I've lost
GP
all memory. Tell me exactly what I'm supposed to type.
as a point data frame. No, not point, not point. Remove the point. It's in French. As data frame.
As data.frame, this one?
Yes.
Okay.
And GPMM cropped.
GPMM cropped. Okay. Then
Mm,
am I
we have
done?
to just a minute.
The rest of you can always help Sylviane out if you've been following today.
Then you say comma
Comma.
and xy
Uh-huh.
equal to,
Equal true, like that.
yeah, maybe, yeah.
Okay.
Could you run to see if it's working?
Okay. Click run.
Maybe I will have
I
error.
now
Oh,
have a database here, GPMM prop to DF.
yes. So in the geom raster, we have to put data again
Okay.
on the ggplot. So in the
Data
geom raster, yeah, GPMM crop df.
prop DF, like that.
Yes, and for the fill, could you
Mhm.
I want to see
Would you like
the
me to run
how
this?
is the data
You can
frame?
see it.
Yes, yes,
So just in
because
case
I
I'm
don't
gonna
know
put
what.
head, it will come out like. Okay. So
We have XY. Mm. Yeah, maybe run with that to see.
Okay. What if I wanted to see every single month?
Then so you
Facet.
we have
You what? Sorry, Victoire?
Maybe to facet,
I facet. Where do I facet?
where they
like
uncomment.
comment.
Yeah,
I uncomment this,
yeah.
I
okay? And I run it now?
no, not yet. I think because we don't have the column math, then it won't work.
Okay, so how do I make that column?
We have to. Let me have a try on my computer first.
So now I have a database, right? I have X, Y, GPM, blah, 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 blah. But what I want is X, Y, month, and then a value rainfall.
You know, just
Anyone else? There's more than Sylvian and Victoire on this, in this group. How about Annabelle? Annabelle, why don't you help us out? What would you do?
Arsen also, can you contribute?
No, so I don't have idea now.
Okay, but can you look through the script and tell me? Because all of this information is right here, which means for the last 1.5 hours, we've been speaking to you and you're not listening. I'll ask again, Annabelle. Do you have an idea of how to do this? I need a column called month. How do I make that column?
so maybe we have to use the pivot longer again, but with
Okay,
this data.
where does pivot longer go?
So we in this that data frame,
Mm-hmm.
just how to say next line. We don't use the same.
Okay,
So we say like GPMM crop TF PIF. That's a new name, for example. PF if yeah. And we say GPMM crop TF.
okay,
And the pipe
right,
and pivot longer.
pivot longer,
And yes, and we say all the columns calls equal to that start
that starts with,
with
like,
with
like that?
yes with how to say it in English, like the string
Okay,
GPM.
so something in quotations,
Yes,
okay,
GPMM
okay,
and you go out of the bracket and comma.
comma,
Yeah, after no, not. Let me have a look. Yes, here, yeah, there, and say names,
what, sorry?
names,
Length,
name. Mm. my name. Names, yeah. Equal to,
So you want names too, and I'll put this on another line so you can see it. Names too,
yes,
okay?
yeah, names to month. Month in a
Okay.
string, yeah. Maybe that's all.
So that's
Mm,
all.
and maybe because we want the rainfall like the same for before, name prefix, names
Prefix?
prefix, yes. Name prefix to wait. GPMM and the dash
Like that,
yes,
okay?
and comma,
Another line. Then another comma,
yep,
okay?
and values to rainfall, for example.
Sorry?
Values,
Values,
value, yeah,
values two,
to rainfall is
like
a
this,
string. Yes.
with an asterisk. Where's your asterisk? Come in. Where's your asterisk? That, like that?
No, like just like without the asterisk,
Oh,
just rainfall. Okay, yeah.
so
And
we,
so here we try to have the month of all the month from the GPMM to a column month and the rainfall. So
okay,
like that we could use the same. Yes,
now
the same thing as
I'm
before.
gonna do
Round.
I'm gonna do something very radical. What if I started the pipe here and I just made one DF instead?
Okay.
I have many data frames and I can't keep track. Will that work?
Mm, I never tried, but maybe. I
Shall
never
we try?
tried to do it like this. Yes.
It works.
Oh, okay.
Do you want to see what GPMM looks like?
Yes.
There we go.
Yeah, it's better now.
So
All right.
maybe Sylvian, now do you think that you will have another GPMM crop it with columns?
Excuse me, Usman?
Do you think that you still have in your environment another GPMM crop it with columns now? With other columns from January to December?
Um,
Basically, if I run this ggplot, am I gonna make a plot? Do you want me to try?
but the feel is not good.
All right, so what do we need to change in fill?
Maybe just make rainfall as Usman did.
All right, now if I run it,
You will have,
did I
yeah,
try?
you have to, yes.
All right, I'm gonna say,
No, it's bad.
I'm gonna add here cropped, so you know that this is a new plot.
But it
Now,
didn't cropped.
someone besides Sylviane, how do I put a shapefile in this plot? You have learnt it last week. How do I put a shapefile? So thank you, Sylviane. You've got us here. We've got a functioning plot. You've helped your professor. How do I now add a shapefile to this plot?
Like choose the mask.
I use a mask. Where do I put the mask? And I want someone besides Sylviane now to talk because Sylviane has helped her professor until this point. Now someone else needs to help.
just remember, now you have plots raster. If it was now a shapefile, how you are going to do? What will change in the ggplot?
Rosalia?
To plot
I want
plot
to add a shape file to this ggplot. How do I do that?
could we use the, I don't know if it will work, like geom_sf at
Okay,
this
and where do
time.
I put geom_sf?
Mm,
Yeah, where? Sorry, Sylvia, I'm asking Rosalia. Rosalia, where? Inside it, in here?
No.
Oh.
No.
So I change this to geom_sf. Like that.
Yeah.
But I wanted to add, not replace. I can run this, but it gives me an error. So I'm gonna go back. It's called GeoMaster. How do I add? I'm being very specific here. How do I add a shape file to this plot? You have all learned this last week. Dowdy, I have not heard your voice yet. How do I add? He's gone. Witness, how do I add a shape file? And we're not moving forward until you guys help your professor. I'm very serious. Do not move.
Yeah.
Just get
No.
them up and sit.
This is very important.
Do you have the script from last time? Oh, you don't.
Well, that means none of you practice when you leave this your room. You don't go practice when you leave this room.
I was practicing like really sharing kind of
Sherry one with myself.
in one of the practicing page skeleton and then we really into
Alright. So, can you tell me how do you plot a shapefile? What's the function we use in ggplot to plot a shapefile?
GeoRaster?
No? GeoRaster.
Yeah.
That's to plot a shapefile. Okay, so Rosalia is saying it's not GeoMaster, so another option?
Yes,
Okay, Arsen, you can speak up because I can't always see, but you said geom_sf. Okay. Now, where does this geom_sf go?
When you say something.
Okay, witness, please speak up because I can't see the chat.
Should I read what she said?
No, I can't see it.
So she's saying, oh, she's in a noisy place. She's suggesting that you add geom_sf after geom_raster.
Okay, so you want me to add it after geom_raster here? And is that enough? That's all I have to do? I want to add the shapefile fakeland_HD. Now what do? I can run this, we can see what happens. I don't have an outline, I don't have a shapefile on that plot. Runs, where's my shapefile?
Where does the data go?
Remember the shapefile is backland HD underscore HD. We want to add it here.
I'll even type it here, you just tell me where you want me to put this. That's your date, that's your shapefile name. Well, does it stay there? Does it go somewhere? Where does it go? What's there looking like you're thinking very hard?
I think that GeoMSF panel would fit on the HD in there.
So I put it inside the GeoMSF, like this? You want me to run it to see what happens? Okay. Anything around the chat?
Change the code equal to code SF with the coordinates.
So I change chord equal to chord SF. Should I run this now? I can run it, we see what happens. So I have an error saying mapping must be created by AES. You supplied an SF object. Now, how do I debug that error? Something's missing.
Maybe include the line code underscore equal,
Where, what, sorry, Annabelle?
saying, I'm trying to, maybe include the line code underscore equal to make it, sync with the shape.
Underscore equal, you mean where the chord SF was, I should change it back to equal,
Yes, yes.
okay? Equal, let me run that. I still have the same error, so it was not chord equal. Let's dissect that error. What is that error? That error is giving you instructions. What is that error asking you to do? Mapping must be created by AES. What does that mean?
Okay, I'm not sure, but, I would propose that in the GeoRaster data equals to, we have to change the aesthetic part of it.
So we have to change the aesthetics in the geom raster. That's what you said?
Yeah, that's what I understood.
And what do we do with changing the aesthetics there, AES there?
Mm. Mm, I'm not sure.
Is it enough to simply just put fakeland underscore HD inside geom Okay, then what else do we need to add inside geom for it to work?
That means in the GeoMSF, the data is Fakeland HD, but then we have to make sure the aesthetics fit.
So I have to say data equals like that,
Yeah,
okay, and then
the, synonymous to the GPMM.
sorry, I didn't hear you.
You would have to add an extra line of aesthetics.
An extra line like this,
No, you have to keep the form in full shape.
okay? You guys are directing me, so I put a comma like that,
Okay.
and then sorry, Annabella, we can't hear you.
From there, let me try, but I'm not sure. Let me try this one.
Could you put it in the chat? You're really low or like we cannot hear you. If you want, I can run this and I show you what happens. Oh no, there's an error. There's something missing inside after the comma. What am I missing after the comma? You tell me what people write in the chat.
I think I'm sure.
Something.
I'll try and do something first on my device. Oh, she's fixing her device.
I'm
But we're
sorry.
not working separately. My friends, we are all one team. You're
Okay,
supposed to help me work on this.
When is
Mm,
it something?
I don't know because I'm still practicing. I'm suggesting
Uh-huh.
after here, maybe we add things on describing that, how do you call it, like color, I don't know, line or
So I put color and line like that.
like maybe color, maybe it's yellow, and then maybe color is equal to,
Like that.
maybe yes, for example,
Okay.
and then you put, how do you call it? Things like maybe line width, maybe line what?
Line what? Like that.
Maybe line width.
Line with this. Like that.
Width, width, line width. Maybe these things too.
Okay. Like that.
Width. How do you call it? I'm
Width.
sorry, my pronunciation.
Okay. Like that.
Like this. Let me chat here. Okay. Maybe it's equal to 0.4, maybe for example.
Something else in the chat?
No, just line width. It's supposed to be one word.
Oh, I put it as one word. Like this.
Yeah. Can you try to run it?
Sure. Object yellow is not found.
Maybe put black now.
Put black.
Black, and then in the color put, how do you call it, semicolon? How do you call it? That thing like semicolon.
Quotations.
Yeah, yeah.
Like that.
Yeah. Can you try to run it again?
Sure. Still telling me that I have a problem.
This.
Now it says can only be used with port SF. So should we put that back?
Annabelle did post something in the chat.
Ooh,
So-
something's happening. So it ran something. What did Annabelle post in the chat?
Right after data about.
Guys, well done. Okay, so we have a plot, but I can't see the raster behind it now. Now what do I do? What if I want to see what the colors behind it?
Please for the children. Yeah, so you can try Annabelle's suggestion.
Uh-huh.
After the data factor HD comma is the aesthetics, AES.
AES,
And then fill
fill,
equals rainfall.
equals rainfall.
In brackets, and the rainfall doesn't have the quotation marks.
So it does not have quotations. Okay. Like this.
Yeah.
All right. Did I spell rainfall correct? Yes, I spelled rainfall. So rainfall is not there. Should I show you what's in Fakeland HD? My attributes are country ID, country, discode, admin 2 and admin 1. So I don't have a rainfall. So shall I remove this aesthetic maybe? Maybe we don't need it?
Like you, and then maintain all other things that she suggested.
Sorry?
Fill equals to an A, then maintain every other thing that she suggested. Yeah.
Like this?
Yeah.
Okay, let's do it. Something's working, something's loading. Let's see. Congratulations, everybody. You have finally helped your professor make a map and put a shapefile on top of that raster. Now, back to the question 30 minutes ago. Notice how the shapefile is irregular, but the raster, the color behind it, is a rectangle. That is the difference between a crop versus a mask. A crop has to always keep the rectangle. A mask will cut it, literally like a scissor on a paper, will cut it to the outline of that shapefile. All right? So now, I do not think you've been able to help your professor, which means that you should be able to do this on your own now.
Yeah.
That for the next 5 minutes or moving on, I want you guys to now use GPM mask and go through the same process here, make that plot of GPM mask and see how it would look different.
Yeah.
Okay, that's your homework.
Now forget the plot function. So use the mask function to, and then come back to the ggplot one to make another maps and see the difference from this.
So now you only have 4 minutes for your rest of the class.
Yeah.
Continue with paper.
I think, yeah, because the exercise it was the same using ggplot with the mask. Want to put the same thing there because here it's will only show like with the function plot. I was asking them to use the ggplot one to do the same, but it's the exercise now. So just tell me if you were able to do that, like use the function mask, which take raster, the cropping raster is a shapefile vectorized to mask and make the same plot like this to see the difference in your mouse. You have 3 minutes, and then there is another exercise that Neymar told you about the.
Then you'll be pitching your project ideas.
Okay, also ask them to share the image.
Yeah. After the maybe 3 minutes.
Just
We will-
so if anybody has done the masking, please paste your plot in the chat so we can see it.
I will follow or without even load the data from the beginning.
You're not following,
No, I'm following.
but you're not doing anything.
Yeah, I'm doing good. I don't have this skeleton on.
So why did you ask for it outside?
You are not in the email list? Oh,
Like, I'm not in ECR.
you should ask.
But then
We are
you-
here.
You're not told everyone that you don't have a script.
You have his trainer, you have.
Thank you, Rika.
Have 1 minute or two maximum. Use the function mask and do the same plots to see the difference here. Mean you have reached the end. Okay, what's something?
Yeah, whatever the proteins.
Okay. So you can share your map via WhatsApp or via the chat. Someone is ready. Now we are jumping to the next component of this session that Nema is going to lead. Thank you, everyone. I am stopping sharing my screen.
Thank you, Osman. Hi again, everyone. I hope you found this to be helpful, but also I think it shows that you need to practice more on your own. So I'd really strongly encourage you to go through again this material when we share the recordings, but also the material on the website has more practice exercises that you can just walk through. You have access to Usman and the rest of the team, so if you run into any issues, please reach out to us. But it's really important that you make sure you have a firm grasp of this material, because when you start working on the independent projects, you may need to revisit some of these concepts. All right, we can then move on to the concept notes. Thank you for the submissions. So we'll do this very quickly. If every team can quickly just walk through their project, I'll assign 5 minutes for each team. And would want to hear just give us a brief overview of your project, what are the project objectives, what approaches you're thinking of using, and the rationale for choosing those approaches. We can start with one of the teams. Do we have anyone who want to go first? Anyone?
Oh my God, today it was intensive. Hi.
Victor, is that
Yeah.
you volunteering?
Yeah, of course.
Okay,
Maybe
go
I
for
can.
it. And yeah, please share your screen.
So we're still in the early stage of our project idea, and
No problem. They don't have to be perfect. We just want to know what you guys are thinking of doing.
yeah. So and I wanted to show what we want to do. So the idea, we want to quantify geographic accessibility to optimize entomological surveillance sentinel site selection in Kasai Central. So in our team, we are with Kaiser, Arsene, and I. And the problem is that in Congo, each province have one sentinel site, and which is not can be not representative of the real actual reality within the province. So that in Kasai Central, which is one of the high value impact and high province in terms of malaria, can have different coverage in terms of environment, but also can be the road accessibility can be affected by seasonality, so that can limit the potential of routine surveillance across the year. So we already checking the literature and we find that the recent effort of National Malaria Program to strengthen the selection of site sentinel is only based on other programmatic indicator has, for example, malaria cases, vector dominant presence, but they are not based on the representativeness of the geographic of the province and the road accessibility across the province. So the aims of the project is to evaluate the current entomological sentinel sites network and try to identify all the accessibility and environmental representative sets of sentinel sites across Kasai Central under different conditions, different seasonal conditions. So we have two objectives that we have two questions that we think maybe we will refine. But the first one is to ask about how the seasonal variation can affect travel time accessibility to the current existing sentinel sites, but also to other potential entomological sentinel sites that we can identify during our work. Then the second question is more about which location should be prioritized for future entomological surveillance when we combine together seasonality, accessibility, environmental representativeness, and geographic coverage. And the objective that we need also to refine, because now it's maybe we need to stop with two objectives. But the first one is to access the seasonality, the seasonal accessibility to the current and potential entomological sentinel sites across season. Then to evaluate also the environmental representativeness of the current sentinel sites. Then to identify the surveillance gap by assessing the combined effect of accessibility and representativeness. Then the last one is to prioritize potential sentinel sites can be served, and by integrating, as I say, seasonal accessibility and environmental representativeness.
You have 2 minutes.
Yeah, the last one, it's then the working package that we try that we think that we can work through. It's like we have 4 working package. The first one, it's more about the seasonal accessibility assessment across the province. Then we have the environmental representativeness across the province. Then the third package is more about the surveillance gap analysis so that we know to put together the work package 1 and 2 to identify the area that is poorly representativeness based on the current surveillance network. Then the last one is to try to rank potential sentinel sites based on the output that we'll get from the package 1 and 2 and 3. So the exact impact that we think that we can have at the end of this project is to improve the understanding of seasonal accessibility content that can affect entomological surveillance activity across the year, and also to identify geographic and environmental area that are underrepresented by the current sentinel sites existing. Then we think that our project can support evidence based on the prioritization of the future sentinel sites, but also to strengthen malaria vector surveillance and vector control planning in Kasai Central. So this is what we want to do, but we think that we need to refine to make it a little bit more focused, because when you read our project in the HTML format, we see that it looks like it's not yet concise. We need to tidy it.
Yeah, thank you so much, Victor. Yeah, as we said, this is just the initial stages. So having it thought through in this way is a good start. And then we'll also just provide more detailed feedback from your submission. I had a quick question. So you outlined that you were considering working on 2 research questions. Are you planning to cover all of those as part of the independent project, or focus on one? Also just considering the time limit.
I think we will consider the time limit, then try to choose what will be more feasible within the time that we have up to September. Maybe we can focus only on one to see what we'll get. Then another one will extend it later. So we completely open on reducing everything to make it time limit constraint that we can have a good product in this time, but only one we can works.
I have a question. There's a lot that is on this objective list.
Yeah.
But I haven't seen anything about how you're getting access to data. So
Yeah,
do you
so
know the ingredients?
yeah. So if you check in because we have only 5 minutes to talk, but if we go through let me go to the HTML document that we have. Where is it? I think, sorry.
So just for the sake of time, like you're welcome to share the HTML later. But just make sure that you have a very clear data plan, like you've got access to the data that you need to do these things. And they fall within the time limit because this is a 2-month project.
Yeah.
And what you shared is certainly for something much more than 2 months.
Yeah, of course. So based on the health system data that we think that we can take it from the grid 3 DRC geospatial database. So they have data on health zone distribution, health area, health facility. Then if we want to add, for example, ontological data, I check the vector atlas database and I found like we have 3 data points across Kasai Central that have existing data.
So how are you going to question about seasonality? Because the health system, the geographical coordinates of sentinel sites are fixed. The road network is fixed. The only thing I see that changes maybe is environmental covariates if you pull out dynamic ones. So how will accessibility turn into something seasonal?
So we start with the question that may across the year, based on the variation, for example, of rainfall, can impact the travel time to reach out to the sentinel sites.
But so I think you need to have a deeper thing.
Yeah.
Because you need to understand how an accessibility model works and the ingredients.
Yeah, of course. Yeah. So you think that
put rainfall in.
Yeah, we from this component we discussed that we hope that Christine can help us to understand how it works.
Okay.
Yeah, because I don't know anything about accessibility model, so that we discuss with Christine by sharing our idea, then we ask them to say we want to understand how it can works.
Okay.
Okay. Yeah, thank you, Victor. And I would encourage you to to reach out to Christina soon, just so that you have an idea of what are some of the limitations that you may run into. But otherwise, yeah, thank you. This looks comprehensive for a start. Good job to the team.
Yeah, well done.
Thank you.
No, Annabelle, it doesn't need to be a PPT. So just whatever you have ready. Like I know you uploaded a Word document.
Yeah. Do you want to go next, Annabelle? And just share the Word document.
Yeah, I'll go next.
I think you may need to stop sharing.
Yeah, I'm trying to look what.
So he said he would change the document, but I'll share what I have because he's not in the meeting. He texted me and told me that he had like a social emergency or something like that.
Annabelle, we can't hear you clearly. Were you saying that Babalola has a more recent updated version of the document?
Yes, but I'll show what I have because he's not in the meeting. He texted me that he has a social emergency to deal with.
Okay, yeah, you can share whatever that you have.
And Annabelle, your team members are you and Babalola?
Yeah.
Okay.
And the version that he has will be published on
Will be-
Spatial, I hope.
The version that he has is the one that has Spatial, and
Okay.
he adjusted a bit on the methodology.
Okay.
Yeah.
Sounds good. Yeah.
So we're going to work on the spatial distribution and determinants of co-occurrence of malaria in anemia. So there's an article that explains in detail that in areas that are endemic for malaria, there is a high prevalence for malaria, for anemia as well. So, but most of the previous studies that have been done, especially in Tanzania and other endemic settings, they treat anemia separately from malaria. So, our main target for this study is to first assess both the spatial distribution and determinants of the co-occurrence of both. So our specific objectives first is to examine determinants for the occurrence of both malaria and anemia in under-5 children. Then to see the spatial distribution of malaria and anemia and identify the hotspots for occurrence of malaria and anemia. Because what our main target is, because most of the malaria interventions, they deal with either, they're known the ITMs or the chemical collapses, but we do not really care about anemia, which is equally another exacerbating factor for the reoccurrence of so we will use the Tanzania Demographic Health Survey and malaria indicator surveys. And then, so our outcome variable is the double burden. That means we won't check the severity of malaria, the severity of malaria or anemia as such. It's just once the child has malaria and anemia, we'll call it as one. Then if a child does not have, has one or does not, has one or does not have both, will be coded as 0. So that would be our outcome variable. Then our dependent variable, I'm still looking for the DHS data set, but I would guess things like age, sex of the child, and all other factors. I'll just brush in briefly. Then, we're planning to use our software to perform analysis. Yes. Thank you. I hope you.
Thanks. So do you have access to the DHS, the raw data?
No, I just requested the website, but they have not replied me. So, yeah.
Let us know if you're struggling, and I can send it to you.
Okay.
Yeah, thank you, Annabelle. I think it's very focused. You have very specific objectives that could be doable within the 2 months period. Yeah, well done.
Yeah, well done. It's a good project.
One question. So, Annabella, I saw you mention about the identification of hotspots. So, how are you going to do that? Are you going to use a model, or you have some threshold that can show you where the spots are located?
I've not yet definitely decided, but I was thinking of a threshold. But I'm yet to discuss with my mentor, the MAP ECR mentor, and also the Babaloa, about what we'll use between a model or a threshold. But I roughly think it's a threshold, but because I'm a little bit less experienced on this matter, I think I'll consider it.
Okay, good luck. Nice project.
Do you have any advice?
Not now, but maybe we will talk more after, And when I have something, I can share with you.
Yeah, thanks, Annabelle. So the last group, who will be presenting?
Okay, can I present, but I will present my HTML document.
Sure.
Yeah, go ahead.
Okay, I'm sorry. You see my screen?
Yes.
Okay, in our group, we are going to investigate the relationship between rainfall variability and malaria incidence in Mozambique. As we know, recently, the events of extreme events have been increasing. So we think we think that there is a relationship in this increase of extreme events of rainfall and malaria. So in our group, we are going to do on that topic, whereby we have choose Mozambique, as it's Mozambique has been getting things like tropical cyclone events, which we think it will be having a relationship with the maybe increase, or as how we do the project, we are going to see. And then we gave a simple introduction and the problem statement, whereby we see that despite the efforts which have been made to reduce the malaria spread, but still climate has been making the things complex. And our general objective is to examine the spatial temporal relationship between rainfall variability and malaria incidence in Mozambique. And our specific objective will be on to examine the spatial, whereby we are going to look on the spatial map and temporal patterns, where we're going to look the trend, what are the interannual variability, maybe is it decadal, maybe the rainfall, and what's the malaria pattern also, and what's the relationship between them. And also we are going to look on the atmospheric circulation, the relationship, whereby we are going to use different methodologies such as composite analysis, whereby we are going to pick those years maybe with the extreme events of rainfall and look, is there any relationship with the malaria incidence, and what was the behavior of the atmospheric circulation during that time. In terms of data, for rainfall, we are going to use the analysis data such as CRIU, which I've already put here. I have access, but we can change it according to the improvement of our output we need. And also we are going to use things like shape files so as we can max the Mozambique well. And in terms of malaria, still we don't have access to it, but Mr. Gerson has said he's going to work on it so as we can get the malaria data. Atmospheric data we are going to use from the NCEP NOAA. I'm sorry, this one is not the updated version of the HTML. In terms of, I try to make like a practice. So as you can see, if this our idea is going to work, just a little, like we try to plot the, how do you call it, for only rainfall, like, but so as we see the climatology, is it like in the initial stages of our research, of our project research, whereby we try to plot the, how do you call it, the rainfall climatology, if we can get a good story so as we can maybe improve our objectives and everything. And from there, once we get the malaria, we are going to integrate everything, and we hope when we get the result, we can get a story to talk, whereby we know recently there have been things about early warning for all, so as people can know if maybe, for example, this year we are talking about there is a possibility of having a strong El Nino, so people can, in terms of health, malaria, they can prepare well. I think this is my end of my concept note. Thank you and welcome from I'm welcoming any comment and input.
Yeah, it's a good project. Just a comment, so Jerson's on the call, right? From what I recall, the DHIS2, the quality of the data really only goes back as far as 2017. And Jerson, you can 110% correct me if I'm wrong for Mozambique. So you might want to consider aligning your timeline because you may only get data going back as far as 2017.
Okay, can I add something there? In terms of when we talk about rainfall, we are going to deal about climatology, but because of the malaria data, it will be, how do you call it, fixed. So we are going to have a elaboration of, maybe we are going to stick on 2017, maybe 2025 if the data is going to reach until there.
Sure. But yeah, otherwise it's a good project. It looks very interesting.
So
Thank
just a quick one, Annabelle. So in case you have in 1 month, like one administration not reporting, for example, are you going to deal with, for example, if you have one polygon with NA in 1 month, are you going to drop that one, or how are you going to deal with?
May you please repeat your question?
I say because you are working with monthly data, it means for your admin, like admin 1 or admin 2, your polygon, you should have in every month values for each polygon. I say if in case, I don't know if it is real, if in case you have one polygon where you have no data in February, something like that. So what are you going to do?
Oh, thank you. So I'm actually not planning to use monthly data. I don't know if this question is really intended for me because I'm just using annual data.
Oh, Annabelle's not using monthly, she's using DHS.
No, it just confused the names. So yeah, sorry, Annabelle, the question was directed to witness.
Yeah, sorry, it's not
Yeah.
Annabelle, sorry, it's witness.
Hello, okay. Pardon, can you repeat your question again?
So I say you are working with monthly data in
Yeah.
Mozambique. For which
Yes,
admin? Well, it is admin 2 or admin 1?
admin 1.
Admin 1. So it
Yeah.
means every month you should have values for every admin 1. But in case your data had some missing monthly reporting, so how are you going to address that?
Is it only 1 month for one region or the whole country?
No, just take 1 month missing in one region, for example.
I think.
So, Osman, is we are going to work on like provincial level. Maybe we can think later how we can consider it. Maybe we can calculate the like average um, of the following, like if we have 1 month and 2 months with data, then maybe we can calculate the median of the case and we can consider it.
Okay.
Yeah, but looking for provincial level, I'm not sure if we're going to have like 1 month without data.
Okay.
Yeah.
Nice.
But
Good luck.
thank you.
Thank you, Witness and Gerson. And yeah, thank you, everyone. These are very interesting topics, and it's good to see that they are applying some components of spatial analysis. So really strongly encourage you guys to revisit that material since it's something that you will be needing as you're working in the projects. We'll have a progress report that you need to submit 1 month into, just to keep you guys on track. More details about the requirements of that will be shared. There will also be shared more detailed feedback of the concept notes that you have submitted. Please do also share the image of the mask map that you just worked on in the session. Do share that in the WhatsApp group before the end of the day. Yeah, that's all for today. If you do have any questions, please don't hesitate to reach out. As you're working more through views and thinking through your projects, do reach out to the facilitation teams. We'll be very happy to provide you with more guidance. With that, we can end here. Thank you again so much, Usman, for these wonderful sessions. And yeah, thank you, everyone. Have a nice week.
Yeah, bye. Don't forget to fill the post-workshop survey. It's again survey with the vector data. So you have both in the same survey. So please fill it. I will share with a slide also in the adequate platforms. Okay, bye.